Hey everyone, and welcome to this explainer. Today, we're diving into a seriously elegant concept, the factory method pattern. If you've ever found yourself totally drowning in tangled code just because you needed to add a couple of new features to an app, well, you are in the exact right place. We're going to explore why creating objects without knowing their exact type up front might literally be the secret to building scalable, flexible, and just truly professional software systems. Let's see what we can uncover. All right, real quick, here's our roadmap for today. We'll start with the object creation problem, move on to thinking like a factory, break down the structure and runtime flow, check out a Java payment system, wavy benefits and comparisons, and finally, talk about exactly when to use it. Let's get into it. Starting off with Section 1, the object creation problem, or as I like to call it, growing pains. So imagine you're building a pretty straightforward food delivery system. It works perfectly, right up until management suddenly asks you to support 50 different food types. Because, apparently everyone wants tacos and smoothies now. This is a super common scaling issue. Think about it. Initially, your system is simple, right? You sell pizza, burgers, and pasta. Life is good. But then the app blows up, it's a huge hit, and management demands a bunch of new menu items. Suddenly you're adding sushi, noodles, rice, and curry. In a basic, naive setup, every single time a new food type is introduced, you actually have to go back in and manually change the core logic of how your app retrieves food. It gets messy fast. And that mess leads us to what we call a classic code smell. You know that massive if-else block? Yeah, that is the exact code smell of using the new keyword repeatedly inside a constantly growing chain of statements. If type equals pizza, return new pizza. Else if burger, return new burger. It's scattered everywhere, it is incredibly tightly coupled, and honestly, it's just a disaster waiting to happen. Developers absolutely dread opening a 1,000-line file that looks like this. So to summarize the fallout of this tight coupling, first, you get repeated object creation, which just leads to bloated, hard-to-read code. You end up with those massive if-else statements we just talked about. This forces frequent, risky modifications that slow down your development and definitely introduce more bugs. But worst of all, it's a direct violation of a massive programming rule, the open/closed principle. Remember, your code should be open for extension, but completely closed for modification. Okay, moving on to Section 2, thinking like a factory. Let's look at a real-world analogy. So the formal definition of the factory method is that it defines an interface for creating objects, but allows subclasses to decide which object to create. What does that actually mean in plain English? Basically, the client, which is your main application, asks for a product, but a dedicated factory handles all the heavy lifting of actually creating it. The client never actually uses the new keyword directly. Think of it like a real-world car factory. When you go to buy a car, you don't personally build the chassis, install the engine, and paint the doors yourself, right? No, you simply ask the factory, hey, I need an SUV, and the factory handles the entire creation process behind the scenes and just hands you the keys. Programming should work the exact same way. You request, the factory delivers. So quick question to think about. Who actually decides which object should be created? You, the customer, or the factory? Well, the answer is kind of the big light bulb moment for this whole pattern. The factory decides. The client just hands over the request, and the factory takes full care of the implementation. All right, Section 3, structure and runtime flow. Let's look under the hood. If we break down the standard Gang of 4 UML design for this, it might look a little complex at first glance, but if we take it slow, it's actually pretty brilliant. You essentially have a product interface. This is the common interface for the objects being created. Then you have the creator. The key here is that the creator relies on the product interface, but it totally leaves the actual instantiation step to a concrete creator class, which is what actually creates the concrete product. It's all about delegating that responsibility. Let's walk through the exact 6-step runtime flow of how this plays out. 1. The client requests a product. 2. The factory receives that request. 3. The concrete factory overrides the factory method to create the specific object. 4. The product is ready. 5. The factory safely returns that created product back to the client. And finally, 6. The client uses it. And notice this whole process happens without the client ever typing the word new. Section 4. Let's look at a Java payment system to get some concrete proof of how this works. This Java example is brilliant for seeing the pattern in action. Say we have an app where a user can pay via credit card, PayPal, or crypto. Instead of the main application trying to figure out how to build all three of those complex payment processors, each payment method gets its own dedicated factory. So we have a credit card factory, a PayPal factory, and a crypto factory. The client just says, hey, process a payment, and the correct factory seamlessly takes over. If we trace the synchronous calls as they happen, you can really see the decoupling in real time. The client requests a credit card payment from the main payment factory. That factory delegates the request to the specific credit card factory. The concrete factory creates the actual credit card object and passes it back up the chain. Finally, the client gets the object and processes the payment. Because of this decoupled flow, the system is totally open for extension. Like, want to add Apple Pay tomorrow? No problem. Just add a new factory. Literally zero existing code needs to change. Section 5. Benefits and comparisons. Let's talk about the why. When we compare life with and without a factory, it's pretty night and day. Without a factory, you're dealing with huge, messy blocks of if-else statements and tight coupling where the client knows every intimate detail of the concrete classes. It's an absolute nightmare to maintain or test. But with the factory method, you get beautiful, loose coupling. The client only depends on abstractions. It's way cleaner, infinitely easier to test using mock objects, and just highly readable. Now, you might be wondering, okay, why not just shove all those if-else statements into one separate class and call it a day? Well, that's known as a simple factory. And sure, it's a step up, but it's still flawed. Because to add a new product, you still have to open up and modify that single simple factory class. The true factory method, which we're focusing on today, relies on a hierarchy and uses inheritance. To add a new product, you simply create a new subclass. It perfectly aligns with the open/close principle. Section 6. When to use it. Let's look at the best use cases. The factory method pattern truly shines in a few very specific scenarios. You absolutely want to use it when the exact type of object you need might change dynamically at runtime. It's also perfect when you know for sure that future extensions are coming, like if you're building database drivers for MySQL, PostgreSQL, and Oracle, or document editors for Word, PDF, and Excel, or maybe integrating various cloud storage providers. Basically, anytime you want to hide the concrete implementation details from the client, this is your go-to pattern. But we've got to be fair and look at the trade-offs. While this pattern promotes incredibly clean and scalable design, it isn't a silver bullet. The major drawback here is that it can definitely increase complexity, because for every new product, you have to create a corresponding creator subclass. That means more files, more classes, and extra layers of abstraction. If you're just building a very small, simple project that you know isn't going to scale, implementing a full factory method might just be a necessary overhead. All right, to wrap things up today, here is a question to leave you with. Look at your own code bases and ask yourself, why is using new everywhere considered bad practice? Seriously, think about the coupling it creates, the testing nightmares it induces, and the barriers it throws up against scaling. I really hope this structured look at the factory method has empowered you to write cleaner, smarter code. Keep structuring your knowledge, and I'll see you in the next explainer.